Hi there! This video series is to display my problem-solving and learning abilities. I hope to show that I can solve any programming problem, regardless of whether I already have expertise in the language at hand. I hope this helps others in my field to learn not just how to solve a particular problem, but how to teach themselves a solution to an unfamiliar problem. For now, I am learning Python. I have no professional experience or formal training in the language, and have only been learning it since mid-January. While I'm picking up fairly quickly, I cannot claim any real expertise. Today, I am going to show my approach to solving the fourth Project Euler problem. Full disclosure, as you can see, I have already solved this, but I'll be starting fresh and talking through my thought process. I will link to both Project Euler and my repository in the description. Let's dive in. So, first, read the problem. Largest palindrome project. A palindromic number reads the same both ways. The largest palindrome made from the product of two two-digit numbers is 9009, which is 91 times 99. Find the largest palindrome made from the product of two three-digit numbers. I'm going to copy this problem statement. We have to make our new script. Once again, forget to do the comment. And then, as before, I'm going to copy over the answers so that we don't have to keep switching back and forth. Okay, so thinking through this problem. One thing that comes to mind, and I remember having this thought process before too, is whether 99 is necessarily one of the numbers. And I don't think that it is. So my naive approach, again, would be something like for, let's say, I in range, and a three-digit number, the first three-digit number is 100, and then we want to go through 1000, although actually we want to start at 1000 and go down to 99. And then we add a step of -1 so that we're going down. And this is 99 because it is exclusive. Most likely we're not going to get anywhere near to the bottom of this. Oh, right, I need a little... Let's do largest palindrome equals 0. No semicolons in Python. That's my Java history cropping up some more. Okay, so for I in range 999, then we're gonna do for I in range same. Actually, this should be a J. You can't loop through with the same variable twice. So, for each number multiplied by each number, we want to first check whether the product is a palindrome. If yes, check whether it is larger than current largest palindrome. If product is smaller than our sorry, I forgot this step in the logic. So yeah, set the largest palindrome to product. Product is smaller than our current largest, then that means we won't get any more in this range, so we want to go to the next one. So go to next I value. So effectively we want to break out of our J loop at that point. And honestly, we probably want to have some logic for breaking out of our I loop much earlier, because it is most likely that our two numbers are going to be in the range 999 to 990. But just in case, let's go ahead with this naive approach. And then I'm just going to throw in our print largest palindrome right now. Okay, so first we have to check whether the product is a palindrome. Oh, right, because I have not written any code up here. Well, we'll fix that right now. So, check whether the product is a palindrome. There's a few different ways that we could do this, most likely. I think the easiest way is to convert the number to a string, so let's see. Product equals. Actually, let's just go ahead and call this string product. We have product equals I times j. String product equals string product. And then list product equals string product dot split, with the separator being empty. And then there's a reverse method in Python. And I'm not sure whether it... I wonder if it can be called on a string. Let's find out. Okay, so looks like no, which is fine. So I'm not 100% certain that this part will work. I'm gonna I'm going to, in an effort to debug, run this with some printing and just kind of see what shakes out, and then stop it in the middle to avoid going through all of the thousands of repetitions that it would do. But first, if list product equals reversed list, then that product is a palindrome. So I actually want F. We can just print out the product there. Obviously, we don't want to just do that, but for the sake of figuring out how well this works, actually, let's go ahead with this. Okay, and we cannot use an empty separator. Believe I ran into that issue previously on a different project. So let's see. Let's try it without a string in there at all. This probably will not work, but let's see. Okay, so it did not find a palindrome at all. So let's do a little bit of a Google here. So how do I start with the language? Python split string into list. So we specifically want to split every single letter apart. So maybe split isn't the right method here. Yes. Ah, that's the one. It's the unpack method, which is this little asterisk. I did learn about that in one of the classes that I explored. And let's get this string product variable out of here. So we just need to do this, and then put our little square brackets around it to say, hey, this is a list though. And then let's see. Once again, I'm running this primarily to check, hey, is this going to work? And it looks like we're having some issues, so let's go ahead and figure it out. So, product found. Product. Okay, see, it goes through all of those very, very rapidly. We don't actually want this entire list, but hey, that's what happens. Let's try that again, but I'll hit cancel sooner. That does not seem to have worked. We'll just make it a smaller loop for right now. Okay. So, let's see. Doesn't look like there are any actual palindromes in that list. Obviously I went through very, very quickly, but that's all it really takes usually. I would expect it to be a number that both starts and ends with a 9. So not that one. So let's go down to 980. Much larger list. Checking the length. So it's 906609. And we are nowhere near that right now. So obviously 999 isn't in the list. But it's got to be in the first 100 values, right? Okay. Let's split this up a little bit more. And obviously this isn't this will give us the answer, but this isn't the way we want to find the answer. We want to actually go through and get the answer programmatically. Right now, I'm just trying to figure out why isn't the reverse list working. And here's what I'm going to do. I'm just going to say if product equals and we'll print out our little list product and our reversed list. Just kind of see what's going on. Oh, and I reverted back to Java syntax once again. So let's not print that. Let's take this back down back to 99. Reverse list none. Okay. So reverse does not give us a return. So what we're going to do here is this, and then on the reverse list, we're going to call the reverse function. Whether this is actually the best of ways to do this, probably not, is my guess. Okay, but at least now we're printing out that our palindromes have been found. So, functional. Which, you know, functionality is always the first step. So, if our product is a palindrome, then we want to say, hey, if... I don't need these parentheses either, because this is Python. If product greater than largest palindrome, largest palindrome equals product. Let's see. Just moving my comments here because I still think they might be useful. And then if product is smaller than our current largest, go to the next I value is going to be if product less than largest palindrome, which obviously it will be false every time we find an actual palindrome, or at least every time we find a largest palindrome. Break. And this should break us out of the J loop, but not the I loop. And that'll just make this algorithm just a little bit more efficient so that we don't have to do quite so many calculations. And actually, let's go ahead and bring back our palindrome found print, just to show that we're not finding all of them anymore. Actually, instead of printing out every time we find a palindrome, let's do palindrome count equals 0. And this is really just for my own making sure that this is working. The way that I expected to. Clearly not part of the requirements, and probably even just counting it slows us down a tiny bit, but Let's go ahead and comment out those two lines for right now, see where we stand. So that finds 2,470 palindromes, and of course the right answer. But if I uncomment these two lines, it only finds 3. So obviously we are saving ourselves quite a lot of the repetition here. Let's go ahead and delete these 2 lines that we do not need. Or, sorry, 3 lines. So, because we already know the correct answer, we know that we are getting the correct answer already, and we're doing so really, really quickly, actually. So, I think part of that is just working in Python. I think there are languages that are less efficient at this sort of task. But we're definitely under that 1 minute mark, and for all that this is an O of n squared, I think that it is a pretty decent solution for this, particularly with this little shortcut taken. So I'm going to call it there for today, and I'll see you in the next one.